Hi everyone, and welcome to my course Azure Load Balancer. In the next few hours, we are going to dive deep into Azure Load Balancer to cover every single aspect of Azure Load Balancer. And actually, we are going to start from the beginning to see where Azure Load Balancer fits in Azure Load Balancing services like Front Door, Traffic Manager, Application Gateway, and Load Balancer. And what will be the use cases that tell us that we should be using Azure Load Balancer? So in this course, we are going to be focusing 100% of the time on Azure Load Balancer only. And I've already created separate videos for other load balancing services. If you're interested to learn any of them, feel free to go ahead and watch my videos. It's important to mention from the get-go that this course is 100% hands-on. There is no PowerPoint slides, no presentations at all. All the time, you're gonna see me either on Azure portal or opening Microsoft Azure documentation to make the course as practical as possible. Because I believe this is gonna be the best way for you to learn Azure Load Balancer properly. Then we will see the different types of Azure Load Balancer: public, internal, and gateway load balancers. Then we are going to talk about zone redundancy and why it's very important in production workloads, and what is the main difference between zone redundant and single zone deployment. Moving on to how to protect our load balancer and configure DDos protection for our load balancer. Then we are going to dive into the inbound rules in more details. We are going to see the inbound load balancing rules and inbound NAT rules separately. And we are going to cover the high availability ports, when we should be using floating IP, and why we need to consider enabling TCP reset on the incoming ports. And as we will be covering the inbound connectivity, we will cover the outbound connectivity as well. We will see the different options we have to allow the backend instances in the load balancer's backend pool to have an outbound connectivity to the public internet, and what's the pros and cons on each of these options, and what's going to be the recommended one to be used in a production workload. Then we will be covering how can we implement egress only or outbound only traffic using the load balancer. Then finally, we are going to look at the monitoring aspects of our load balancer to see how can we use different monitoring tools to keep an eye on our load balancer and get alerted or notified when something unexpected happens. That's enough for an introduction for this course. Now let's get started and let's learn Azure Load Balancer together. Hi everyone, in this video we are going to talk about Azure Load Balancer at a very high level. And as the name suggests, Azure Load Balancer distributes the incoming traffic evenly across resources in the backend pool. And we have two types of load balancers: public load balancer and internal load balancer. For the public load balancer allows you to accept incoming traffic coming from the public internet. And the best use case for it is to use it in front of your web tier to allow the load balancer or the public load balancer to accept the traffic coming from your clients over the internet. However, for the internal load balancer, it doesn't have this benefit. Internal load balancer only accepts traffic coming from the VNet. It only accepts internal traffic. Internal load balancer cannot accept internet traffic. So as you can see in this example here, the public load balancer will be able to accept traffic coming from the clients over the internet. And then the public load balancer is going to distribute the traffic to different VM in the backend pool, which is going to be our web tier. Then we are going to be sending all the traffic from these VMs to an internal load balancer. And again, the internal load balancer is going to distribute the traffic to different VMs in the business tier of our architecture. This is again a very high level architecture to show you how can we combine both public load balancer and internal load balancer in one architecture. At this point, someone might say, we have so many load balancing services in Azure. We have front door, application gateway, traffic manager, and now we have load balancer. It's going to be so confusing to use the right Azure load balancing service for a specific use case. And for this reason, I'm going to show you this comparison table that will make the life easier for you to select the right Azure load balancing service. So this table here makes a comparison between different Azure load balancing services across 2 dimensions, whether it's global or regional, and whether it's HTTP or non-HTTP. And by answering these 2 key questions, you will be able to land on the right service that will fit into your architecture. I'm going to show you an example. Let's say that we have a requirement to have a global service, a global load balancing service. In this case, we only have to choose from Azure Front Door or Azure Traffic Manager, because these services are the 2 global services we could be using. Now, let's ask ourselves the second question. What kind of traffic we should be supporting? If it's HTTP traffic, then we will have only one option, to use Azure Front Door in our architecture. And if it's non-HTTP traffic, then we can only use Traffic Manager. And let's turn it around to the regional case. And let's say that we want to use an Azure load balancing service in a regional scope. And in this case, we have only 2 services to choose from, either an application gateway or Azure load balancer. Then coming to the second question, what kind of traffic we are supposed to support? And if it's HTTP traffic, then we can be using application gateway only. However, if we want to use non-HTTP traffic, then we can use Azure load balancer. Again, this table is very important to show you the key differences between Azure load balancing services. And it allows you to select the right Azure load balancing service that will fit into your requirements and your architecture. Now, coming back to our load balancer diagram, at a very high level again, the load balancer allows you to distribute the traffic across availability zones, across regions, allows you to develop health probes to see or to know the health status of the backend services in the backend pool, allows you to do a lot of things, which you are going to see in more details in the next videos. That's all I have for you in this video, to just show you a very high level overview of Azure Load Balancer. I hope you enjoyed this video, and I'm gonna see you in the next video. Thanks for watching. Hi everyone. In this video we are going to see how can we create a public load balancer. So we are going to create a load balancer and 2 VMs, and we are going to see how can we configure the load balancer to distribute the traffic to these 2 VMs. But before we get to that, we need to create a virtual network first, so we can put our resources in it. So let's go ahead and create a new virtual network. And let's create a new resource group. I'm gonna call it RG Sydney. And I'm gonna call our VNet Sydney as well. And I'm going to put it in Australia East region. Let's go ahead and create our virtual network. Then I will need to create a NAT gateway to allow an outbound internet connectivity for the resources in the VNet we have just created. So let's go ahead and create a new NAT gateway. Let's select Sydney resource group. Let's call it NAT gateway Sydney. And let's leave everything else to the default value. And then let's go ahead and create our NAT gateway. Now let's go ahead and create our load balancer. Now let's go ahead and create a new one. And let's put it in Sydney resource group. Let's call it public load balancer. And I'm gonna use a standard SKU public type, regional tier. And let's go to the Frontend IP configuration. And let's add a new one. Let's call it load balancer IP. And then let's select IPv4, IP address, and let's create a new public IP address. Let's call it PIP. And then let's leave everything to the default values. And let's go ahead and add our front-end IP configuration. Now, let's go to the backend pools and let's add a new backend pool. Let's call it Backend. And let's select our virtual network we have created before. And since we don't have any VMs at the moment, I'm going to leave the backend configurations empty. And I'm going to show you how we are going to associate the VMs to this load balancer while we are creating the VMs. But for now, let's go ahead and save our backend pool, and let's go to the inbound rule. And let's go ahead and add a load balancing rule. Let's call it rule 01, and let's select the front-end IP address of our load balancer, and let's select our backend pool. Let's specify port 80, backend port 80 as well, and let's create a new health prop. Let's call it health prop, and then let's select TCP protocol and leave everything to the default values, and let's enable TCP reset setting, and then let's add this inbound rule. Now let's go to the outbound rule. We don't need to do anything in this at the moment, so let's go all the way down and create our load balancer. Now, as I said in the beginning, we need to create two virtual machines. So we are going to use them to test our load balancer. So let's go ahead and create our first VM. Let's put it in Sydney resource group. I'm gonna call it VM01. And let's specify username and password for the VM01. And let's leave RDP port open to allow us to connect remotely to the VM. However, you should never do this in production environment or any other environment, to be honest. A better way to connect to your VMs is gonna be a Bastion host. However, it's not in the scope of this video. Now, let's go to networking and making sure that the VM is gonna be hosted in the VNet we have created. And let's scroll all the way down and click on Advanced for NIC Network Security Group. Click on Advanced. However, we are not going to configure it at the moment until we select our load balancer. So let's tick on the load balancer checkbox, and let's select our load balancer, and let's select our backend pool. Now let's go up to configure our network security group, and let's go ahead and create a new one. Let's add an inbound rule. Let's select HTTP traffic, port 80 to allow the traffic, and then we are gonna give it priority 100. And let's add this rule, and then let's go ahead and add it. Then let's go all the way down and create our VM01. Now let's do exactly the same for the second VM. So let's go ahead and create a new VM. Let's put it in Sydney resource group. Let's call it VM02. Let's specify a username and password for VM02. And let's leave RDP port open. Let's go to networking, making sure that we are using the same VNet we have created before. Let's use the advanced NIC network security group. And let's tick on the load balancing checkbox. And let's select our load balancer we have created before and our backend. Now let's go up to configure our network security group. And let's add an inbound rule for HTTP traffic. And let's give it priority 100. And let's go ahead and add this rule. Now let's go all the way down and create our VM02. In order to be able to test our scenario, we will need to install IIS on these two VMs. So let's open Cloud Shell terminal on these two tabs. And we are going to use PowerShell to install IIS on these two VMs. So let's paste this command that I'm going to leave in the description box. And let's specify some parameters. Resource group name RG Sydney and VM name VM01. And let's install IIS on VM01. Now let's go to VM02 and do exactly the same. Let's paste our command and let's specify our parameters. RG Sydney for the resource group name and VM02 for the VM name. And let's go ahead and run this command. Alright, now we have the IIS installed on both VMs. So let's go back to our load balancer and let's browse to the front-end IP configuration. And let's copy the IP address of our load balancer. And let's open a new browser tab and let's paste our IP address. As you can see here, it browse to VM01. And no matter how many times you browse, it is gonna stick to VM01 because of the caching. So let's open incognito window and let's paste the IP address. As you can see here, it went to VM02. This is just to show you how can we create a public load balancer and configure it to distribute traffic across multiple VMs. Now, let's go ahead and clean things up. I'm gonna browse to resource groups and I'm gonna go to RG Sydney and I'm gonna delete the resource group. So it's gonna delete all resources we have created in this lecture. Let's go ahead and delete it. That's all I have for you in this video. Thanks for watching and I will see you in the next video. Hi everyone. In this video we are going to see how can we create an internal load balancer. And it's very similar to the previous video when we created the public load balancer. However, there are few configurations we need to make in order to make the internal load balancer scenario works. And similar to the previous video, we are going to create a load balancer, few VMs, and of course we need to put them in a virtual network. So let's go ahead and create a new virtual network. And let's create a new resource group first. Let's call it RG Sydney. And let's call our VNet name VNet Sydney as well. And let's put it in Australia East region. Let's go ahead and create our VNet. And let's create a NAT gateway to allow the outbound internet connection from the resources we are going to place in the VNet. Let's put our NAT gateway in Sydney resource group. Let's call it NAT gateway Sydney. And let's leave everything else to the default values. And let's go ahead and create our NAT gateway. Now let's go ahead and create our load balancer. Let's go ahead and create a new one. Let's put it in Sydney resource group. Let's call it internal load balancer. It's gonna be a standard. We're gonna use internal type this time and it's going to be regional. Let's go to the next tab and let's go ahead and create a front-end IP configuration. Let's call it load balancer IP. And as you can see here, the virtual network has been already selected for me. I'm going to choose the subnet and then making the availability zone to be zone redundant. Pretty much the default values. Let's go ahead and add the front-end IP configuration. And let's go ahead and configure our backend pool. Let's call it backend. And again, since we don't have any VMs created yet, we are gonna leave it empty. And we are going to assign the load balancer to the VMs at creation time. Now let's go ahead and save our backend pool. And let's go to the next step and configure the inbound rules. And let's go ahead and add a load balancing rule. Let's call it rule 01. And let's select the front-end IP address of our load balancer. Let's select our backend pool, and let's specify port 80. And let's create a new health probe. Let's call it health probe. Let's specify port TCP protocol and leave everything else to the default values. And let's enable TCP reset. Let's go ahead and add the inbound rule. So we don't need to specify any outbound rule. So let's go all the way down and create our load balancer. Now, let's go ahead and create 3 VMs. 2 VMs are gonna be internal without any public access to the internet. And then the third one we are going to have as a test VM to allow us to test this scenario. Now, let's put our VM in Sydney resource group. And let's call the VM VM01. And let's specify a username and password for VM01. Let's leave RDP port open. Let's go to networking, making sure that we are using the same VNet we have created in this video. And let's enable the advanced network security group. And let's go ahead and configure it by adding a new inbound rule for HTTP traffic on port 80, and let's give it priority 100. And let's go ahead and add the network security group, and then let's stick on the load balancing and select our internal load balancer and the backend pool. Now let's go all the way down. One important thing I forgot to mention is that we want to disable the public IP address on this VM. As you can see here, the public IP here, it's gonna create a new one for me. So we are not going to create a public IP address for VM01. Now let's go all the way down and create VM01. Now we are going to do exactly the same for VM02. We are going to put it in Sydney resource group. We are going to call it VM02, and we are going to specify username and password for VM02. I'm gonna leave RDP port open. Then let's browse to networking, making sure that we are going to use the same VNet we have created in this video. Let's use advanced network security group, and let's add a new inbound rule on HTTP traffic on port 80, and let's give it priority 100. And let's go ahead and add this new rule. Now let's stick on the load balancing and select our internal load balancer and the backend pool we have created. Not to mention that we need to not to create a public IP address on VM02 as well. Now let's go all the way down and create VM02. Now the third VM we are going to create is going to be a test VM. So let's put it in Sydney resource group, where I'm gonna call it test VM. And again, I'm gonna specify a username and password for my VM. And I'm gonna leave RDP port open, going to networking, going to choose the same VNet we have created in this video, and I'm not gonna specify any load balancing or any configuration. This is simply the VM we are going to use to connect to the internal load balancer. Now let's go all the way down and create our test VM. Alright, now we need to install IIS on VM01 and VM02. So let's go and open Cloud Shell Terminal on these two tabs, so we can install IIS using PowerShell script. Now, let's paste this command that I'm going to leave in the description box, and let's specify our resource group, RG Sydney, and VM name VM01. And let's go ahead and install IIS on VM01. And let's go to the second tab and paste the PowerShell script, and let's specify the resource group and the VM name to be VM02. And let's go ahead and run this command as well. Alright, now we have the IIS installed on both VMs. Let's go to test VM and let's connect to it to test our scenario. Let's connect it using RDP and download RDP file. Now I'm gonna use a username and password I used to configure the test VM, and let's connect to our test VM. Alright, now let's go to the local server here and let's disable the enhanced security configuration for IE to allow us to test our scenario. Now let's open Internet Explorer and let's go back to my load balancer. And let's go to the Frontend IP and let's copy the IP address of my internal load balancer. And let's go back to my VM. Opening the IE and let's paste the IP address of the internal load balancer. As you can see here, it directed me to VM01. And as you can see, as I'm refreshing the page, sometimes it brings up VM01, sometimes it brings up VM02, because again, as we said, that's an internal load balancer. Now, let's open a new browser tab and let's paste the same IP address of the internal load balancer and see if we are going to get any luck hitting the internal load balancer and hopefully getting browsed to VM01 or VM02. Technically, we shouldn't be able to do that because we have configured an internal load balancer at the first place. And this is the main difference between the public load balancer and the internal load balancer. Now let's go ahead and clean things up. Let's go to resource groups and let's select RG Sydney and let's go ahead and delete the resource group. That's all I have for you in this video. Thanks for watching and I'm going to see you in the next video. Hi everyone. Before we get further into our course, I just wanted to give you a quick heads up. As you already know that this course is completely hands-on, so you should be expecting to spend so much time on Azure portal, creating different services and configure different components. And as a result, this will add a little bit of cost on your monthly bill. And in my case, it costed me around 30 Australian dollar to create this course. And I created this course in a way that will allow you to get rid of the resources you create on Azure portal really quickly. So you don't have to hold on a resource too long until you finish the course. I did this specifically to make each video stand alone by itself, with minimum dependency on the previous or next videos. Having said that, in some situations I found it better for you to keep on the resources for 2 or 3 videos to just save time and avoid recreating the resources we are going to use in a very short time. This is just a quick note I wanted to give you before you get started with my course. If you are not happy paying any more cost in your Azure bill, so please don't create any resources and just watch what I'm doing. Thanks for watching and I will see you in the next video. Hi everyone. In this section we are going to talk about the load balancer core elements. Starting from creating multiple VMs and using the inbound NAT rules to direct traffic to each VM separately. And we are going to look at how can we configure the availability zones for our load balancer, or even better, how we use the zone redundancy option in Azure Load Balancer. In addition to how we create a global load balancer, gateway load balancer, and integrate a NAT gateway with our load balancer. And lastly, we are going to see how can we use DDos protection for our Azure load balancer. Let's get started, and I'll see you in the next video. Hi everyone. In this video, we are going to see how can we use the inbound NAT rule of the load balancer to direct the traffic to multiple VMs through the IP address and the port number. And in this video, we are going to create some VMs and a load balancer. And of course, we need to place them in a virtual network. So let's go ahead and create a virtual network. I'm gonna create a new resource group. I'm gonna call it RG Sydney. And I'm gonna call my virtual network VNet Sydney as well. And I'm going to put it in Australia East region. And let's go ahead and create the virtual network. And now let's go ahead and create a NAT gateway. And I'm going to put it in Sydney resource group. And I'm gonna call it NAT gateway Sydney. And let's leave everything else to the default values. And let's go ahead and create our NAT gateway. Now let's go ahead and create two VMs that we are going to use in this scenario. So let's create our first VM. And I'm gonna put it in Sydney resource group. Let's call it VM01. Let's specify a username and password for my VM. Let's leave RDP port open. Let's go to networking and make sure that it's been deployed in my VNet, Sydney VNet. And let's use the advanced network security group option. And let's allow the inbound rule on HTTP protocol on port 80. And let's give it priority 100. Let's go ahead and add this rule. And let's go all the way down. We haven't created our load balancer yet. So let's go ahead and create our VMs and see how we are going to associate the VMs to the load balancer from the load balancer. Let's go ahead and create our first VM. And let's create it. And let's do exactly the same on the second VM. Put it in Sydney resource group. Let's call it VM02. Let's specify a username and password for VM02. And let's leave RDP port open. Go into networking, make sure that it's gonna be deployed in Sydney VNet. And let's select advanced option of the network security group. And let's allow inbound rule for HTTP traffic on port 80. And let's give it priority 100. And let's add this inbound rule. And again, we haven't created our load balancer yet, so we are going to associate it with our load balancer while we are creating our load balancer. Let's go ahead and create the second VM. Now we need to install IIS on these two VMs. So let's go to our first VM and open a Cloud Shell terminal on both VMs. And we are going to use a PowerShell script to install IIS on these VMs. And I'm going to leave this script in the description box. And now let's change some parameters. Resource group name, it's gonna be RG Sydney, and the VM name, it's gonna be VM01. And let's go ahead and run this command. And let's do exactly the same on the second VM. Let's put RG Sydney in the resource group, and VM name, it's gonna be VM02, and let's run this command as well. As we are waiting for the IIS to be installed on these VMs, let's go ahead and create our load balancer. Let's put it in Sydney resource group, Let's call it load balancer. Australia East region, standard, public, and regional. Now let's go to the next step and let's create a front-end IP address. Let's call it load balancer IP address. And then let's create a public IP address to be the front end of my load balancer. I'm gonna call it public IP and leave everything to the default values. And let's go ahead and add this front-end IP. Now let's go to the next step, going to the backend pool and add a new pool. Let's call it backend. And we are going to select Sydney VNet that we have created before. And now let's add some resources to the backend. We are gonna add these two VMs we have created to be in the backend pool for our load balancer. Let's go ahead and add this backend pool and let's save our changes. Now let's go to the next step. For the load balancing rule, let's add a new load balancing rule. Let's call it rule 01. And let's select the front-end IP of our load balancer and the backend pool, port 80, backend port 80, and then let's create a health probe. Let's call it health probe. And let's select TCP protocol and let's enable TCP reset. And now let's go all the way down and create our load balancer. Alright, now my load balancer is created and the two VMs have the IIS installed on them. Now let's go to my load balancer. Let's browse to front-end IP and let's browse to the public IP address of my load balancer. And as you can see, it opens VM01, and as we refresh, we are going to get VM02. Now, so far there is no difference from what we have done before. We have a load balancer, distributes the traffic to two instances in the backend pool. Now we want to use the inbound NAT rule to allow the load balancer to direct the traffic to a specific VM instance based on the port number. So let's go ahead and see how can we do this. Let's browse to inbound NAT rules and let's go ahead and add a new NAT rule. I'm gonna call this one VM01 rule. And let's select the VM machine and let's select the IP address, the private IP address of our VM. Now let's select the public IP address of my load balancer. Now we are going to specify which port we want to use on our load balancer to accept the traffic and then forward it to VM01. So I'm going to specify port 81. And then for the backend port, let's specify port 80 because we are using HTTP traffic. But as you can see here, it doesn't allow me to do this because the backend port has to be unique across inbound NAT rule and the load balancing rule. So if I'm gonna go a step back, as we are creating the load balancer, we have already created a rule on port 80 for these VMs, and we cannot have duplicate rules on these ports. So what I'm going to do now is to delete this rule to allow us to add inbound NAT rules for specific VMs. However, if you want to have both, you just need to go to the VM and allow multiple ports, allow the VM to listen to multiple ports to accept the traffic coming from the load balancer. However, we are not going to do that. It's not the main scope of this video. Now let's browse back to inbound NAT rules and let's add a NAT rule. Let's call it VM01 rule and let's select the VM01. It's a private IP address and the public IP of my load balancer. Let's select the port 81 and the backend port is going to be 80. And as you can see now, it didn't give me the same warning it gave me before. Now let's go ahead and add this NAT rule. Now let's go ahead and add my second NAT rule for VM02. And we are going to select VM02. It's a private IP address, the front-end IP of my load balancer. Let's select port 82 and sending the backend port to be 80. Let's go ahead and add my second inbound NAT rule. Now we have created our two rules. Let's go and test it. So this is the front-end IP of our load balancer. So let's add port 81. And as we have configured our load balancer, any traffic coming to port 81 is going to be directed to VM01. So let's try the same, but with port 82. It should get directed to VM02. This is exactly how we have configured it in VM02, to sending all traffic coming on port 82 to VM02. So this is to show you how can we use the inbound NAT rules to configure routing on different VMs based on the port number. Now let's go ahead and clean things up. Let's go to resource groups and let's delete Sydney resource group. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to see how we are going to deploy multiple VMs in an availability zone. And then we are going to use a load balancer to distribute the traffic evenly across all of these VMs in a specific availability zone. And of course, we will need to create a virtual network to put in all of our resources. So let's go ahead and create a virtual network. And I'm gonna create a new resource group. Let's call it RG Sydney. And I'm gonna create a VNet. I'm gonna call it VNet Sydney in Australia East region. And let's go ahead and create my virtual network. Now let's create NAT gateway to allow outbound internet connection to all of the resources we have in the VNet. Let's put it in Sydney resource group. Let's call it NAT gateway Sydney. And let's leave everything else as the default values. And let's go ahead and create the NAT gateway. Now let's create two VMs. So let's create the first VM. And I'm gonna put it in Sydney resource group. Let's call it VM01. And when it gets to the availability options, I'm going to choose availability zone. And I'm going to choose zone 1. And this is going to be the zone I'm going to use to deploy all of the VMs, including the load balancer. So I'm going to use a specific zone to have all of the resources, and the load balancer is going to distribute the traffic evenly to all of the VMs in this zone. Now let's go ahead and specify a username and password for my VM. Let's leave RDP port open. Let's go to networking. Make sure we are using Sydney VNet. Let's select the advanced network security group configuration, and let's allow inbound rule for HTTP traffic on port 80, and let's give it priority 100. And let's add this rule, and we don't have a load balancer yet, so we are going to associate it with our load balancer later on. Now let's go ahead and create our VM. And let's go ahead and create it. Now let's do exactly the same on the second VM. Let's create a VM and put it in Sydney resource group. Let's call it VM02. For the availability options, let's choose availability zone and let's select zone 1. Now let's specify username and password for my VM. And let's leave RDP port open. And let's go to networking. Make sure it's gonna be deployed in Sydney VNet. And let's use the advanced configuration for my network security group. And let's allow inbound rule for HTTP traffic on port 80. And let's give it priority 100. Let's add this rule, and again, we don't have a load balancer yet, so we are gonna associate it to our VM later on. Now let's go ahead and create our VM. Let's go ahead and create it. As you already know, we will need to install IIS on these VMs to allow us to test this scenario. So let's open Cloud Shell Terminal on these two tabs so we can run a PowerShell script to install IIS on our VMs. Alright, now let's paste this command that I'm going to leave in the description box, and let's adjust some parameters. Let's call the resource group RG Sydney and the VM name VM01. Let's go ahead and run this command. Let's do exactly the same on VM02. Let's specify resource group name to be RG Sydney and the VM name to be VM02. And let's run this command as well. Now, while we are waiting for the IIS to be installed, let's go ahead and create our load balancer. And let's go ahead and create a load balancer. Let's put it in Sydney resource group. Let's call it Zone 1 load balancer. And it's gonna be in Australia East, standard public regional load balancer. Let's go to the next step and add a front-end IP configuration. Let's call it again Zone 1 load balancer IP. And let's create a public IP address. And let's call it Zone 1 public IP. And in here we are going to do some changes. Usually we go for zone redundant when it gets to the availability zone. But in this scenario, we want to deploy all of these resources in one availability zone. Load balancer and all VMs are going to be deployed in zone 1. So I'm going to change the availability zone to be in zone 1. And let's go ahead and add the IP. Now let's go to the next step and add a backend pool. Let's call it backend, and let's select the VNet of my resources. And then let's go ahead and add the VMs I've created before. And let's save my backend pool. Let's go to the next step and add a load balancing rule. Let's call it load balancing rule. Let's select the front end IP address of my load balancer and the backend pool, port 80, backend port 80, and let's create a health probe. Let's call it health probe. And the protocol I'm going to use is TCP. Let's go ahead and add this health probe. And let's enable TCP reset. Now let's go all the way down and create my load balancer. Now my load balancer has been created and ready for me. Let's browse to the front end IP. And let's browse to this public IP address. And as you can see here, we have been able to hit our VMs in zone 1. So in this scenario, we have deployed all of our resources, the load balancer and our VMs in zone 1 in my region. So I'm not going to delete these resources because I'm going to need it in the next few videos to show you how we are going to use a multi-zone load balancer and cross-region or a global load balancer. I hope you enjoyed this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to see how we create a load balancer and use it to distribute traffic across VMs in different availability zones. So let's go ahead and create two VMs. Let's go ahead and create the first one. Let's put it in Sydney resource group. Let's call it VM03. And for the availability options, I'm gonna choose availability zone, zone 2. And let's specify a username and password for my VM. And let's leave RDP port open. And let's go to networking. Make sure it's gonna be deployed in Sydney VNet. And let's go to the advanced network security group configurations. And let's allow inbound rule on HTTP port 80. And let's give it priority 100. And let's add this rule. And let's go all the way down and create our VM03. Now, let's go ahead and create our fourth VM. It's gonna be VM04. So let's put it in Sydney resource group. Let's call it VM04. And for the availability option, let's choose availability zone. I'm going to put it in zone 3. And now let's specify a username and password for my VM. Let's leave RDP port open. Let's go to networking. Double check it's gonna be deployed in Sydney VNet. And let's choose the advanced configuration of my network security group. And let's add an inbound rule, allowing traffic on port 80, HTTP traffic on port 80. And let's give it priority 100. And let's go ahead and add this rule. Now let's go all the way down and create our VM. Now we need to install IIS on these two VMs. So let's open Cloud Shell Terminal in these two tabs to install IIS on these VMs. So I'm going to use this PowerShell script that I'm going to leave in the description box. And I'm going to change some parameters. Resource group name, it's gonna be RG Sydney, VM name VM03. And let's go ahead and run this command. And now let's do exactly the same on the other Cloud Shell terminal. Let's paste this command and change some parameters. RG Sydney and the VM name VM04. And let's go ahead and run this command. Now, let's go and create our load balancer. So let's go ahead and create a new one. Let's put it in Sydney resource group. Let's call it multi-zone load balancer. Because the VMs that are going to be associated with this load balancer sets in different availability zones, zone 2 and zone 3. And it's gonna be standard, public, and regional. Let's go to the front-end IP configuration and let's add a name for our front-end IP. It's gonna be multi-zone load balancer IP. And let's create a public IP address. Let's call it multi-zone public IP address. And for the availability zones, we are gonna keep it zone redundant, because we are using this load balancer to distribute traffic to VMs in different availability zones. It will be best for us to use zone redundant option rather than loading or deploying the load balancer in a specific availability zone. Now let's go ahead and add this front-end IP, and let's go to the next step and add a backend pool. Let's call it backend. And let's select Sydney VNet and let's add the two VMs we have created this video, like VM3 and VM4. And let's go ahead and add them and let's save our backend pool. Let's go to the next step and let's add a load balancing rule. Let's call it load balancing rule. Let's select the front-end IP address of our load balancer and then let's select the backend pool. Port 80, backend port 80. Let's create health probe. Let's call it health probe. And it's gonna be using TCP protocol. And let's enable TCP reset. And let's go ahead and add this rule. Now let's go all the way down and create our load balancer. Alright, now my load balancer has been created for me. Let's browse to the IP configuration of my load balancer, and let's browse to the public IP of my load balancer. And as you can see here, it's gonna hit VM03 and VM04 because that's how we have configured our load balancer to distribute traffic to different VMs in different availability zones. Again, I'm not gonna delete the resources in this video because I'm going to use it in the next video to show you how to create a cross-region or a global load balancer. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to create a global load balancer or cross-region load balancer. Now let's go to load balancers. And in previous videos, we have already created 2 load balancers. If you remember, Zone 1 load balancer, we created it when we wanted to distribute traffic to VMs created in the same availability zone. While the multi-zone load balancer, we created it to distribute traffic to VMs created in different availability zones. Now we are going to take it one step further, and we are going to create a global load balancer to distribute traffic to these 2 load balancers. So let's go ahead and create our global load balancer. Let's put it in Sydney resource group. Let's call it global load balancer. And this is one important point you need to be aware of when it comes to the global load balancers. And the portal doesn't do enough validation for it. We are only allowed to use specific regions for cross-region load balancer or global load balancers. If we decided to use any other region, the portal at that point, as of March 2023, is not going to give you any validation error. And it's gonna keep going, and then when you try to deploy that resource at the end, it's gonna fail. So from the get-go, make sure you are gonna be using any of these regions. They call it home regions when you create a global load balancer. So I'm going to use ESTUS2 for my global load balancer. And I'm gonna use standard, public, and global. Now let's go to the next step, and let's add a front-end IP configuration. Let's call it global load balancer IP, and let's create a public IP address. And let's call it global load balancer public IP address. And let's go ahead and add this IP. Now let's go to the backend pools, and let's add a backend pool. And as you might notice, it looks already different from the backend pool of the regional load balancer. So let's call it backend pool. And this is one of the key difference between global load balancer and others. In global load balancer, we are allowed to select other load balancers as a backend target in our backend pool. So I'm going to select a multi-zone load balancer as a backend target. And I'm going to select the front-end IP address for it. And same thing for the zone 1 load balancer. I'm going to add it as a backend target in my backend pool. Now let's go ahead and save our backend pool, and let's go to the next step and create a load balancing rule. Let's call it load balancing rule. And I'm going to select the front-end IP address of my load balancer and the backend pool. And let's use port 80, and let's enable TCP reset. Now let's go ahead and add this rule, and let's go all the way down and create our global load balancer. Alright, now my load balancer has been created, so let's browse to the IP address of my global load balancer, and let's try to hit it. As you can see here, we are getting VM1, and again because of the browser cache, so let's copy it across to Cognito and see what we might be able to get, VM4, because this load balancer distributes the traffic to other load balancers we have created before. So it's kind of a load balancer for load balancers, so to speak. That's all I have for you in this video. Again, I'm not gonna delete the resources because I'm gonna use it in the next video. I hope you enjoyed this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to see how can we create a gateway load balancer. So let's go to load balancers, and let's go ahead and create a new load balancer. Let's put it in Sydney resource group, and let's call it gateway load balancer. It's gonna be gateway, internal, and regional. Let's go to the front-end IP configuration, and let's add a new one. Let's call it gateway load balancer IP, and let's put it in the default subnet, and let's make it zone redundant, and let's add the front-end IP configuration. Now let's go to the backend pool. Let's go ahead and create a new backend pool, and let's leave everything to the default values, and let's add some backend targets, and let's add some VMs, and let's go ahead and save our backend pool. Now let's go to the inbound rules and add a load balancing rule. Let's call it rule, and let's select the front-end IP address of our load balancer and our backend pool, and let's create a health probe. Let's call it health probe, and let's select TCP protocol, and let's add it. Now let's go all the way down and create our gateway load balancer. Alright, my gateway load balancer is now ready for me. Now I'm going to show you how we are going to use it with other load balancers. So I'm gonna go to Zone 1 load balancer and browse to the front-end IP configuration. And then in here you will be able to see the gateway load balancer. And from here we should be able to associate the gateway load balancer to our regional load balancer we have created before. Let's go ahead and save our changes. And this is not the only use case for the gateway load balancer. If we also browse to one of our virtual machines, let's say VM01, and then when we go to networking, browse to the network interface of our VM, and let's go to the IP configurations, we should be able to associate the gateway load balancer to the VMs as well. And these are the different use cases of the gateway load balancer. And again, I'm not gonna delete these resources because I need it for the next video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to see how can we integrate a load balancer with a NAT gateway. So let's browse to NAT gateway that we have already created in a previous video. And let's go to the outbound IP address. And as you can see here, we don't have an outbound IP address for our NAT gateway. So let's go ahead and create one. Let's create a new public IP address for NAT gateway public IP address. And let's go ahead and add this one and save our changes. Alright, now we have got an outbound IP address for our NAT gateway, which is gonna be presented or used for all outbound traffic from our VNet and subnet to the public internet. So if we go to virtual machines, for example, and if we connect it to VM04 using RDP connection, and let's connect to the VM using the username and password we used when we were creating the VM. Let's browse to local server And let's disable the enhanced security configuration for IE to allow us to test our scenario. Now, let's open IE and let's browse to whatsmyip.com. As you can see here, 179.204. This is going to be the IP address of the outbound address we have created, 179.204. This is to show you that all outbound internet connections are gonna be presented by the outbound IP address we have created for our NAT gateway. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to see how can we do a DDoS protection for our load balancer. So let's go ahead and search for DDoS plan. And let's go ahead and create a new DDoS protection plan. Let's put it in Sydney resource group. Let's call it DDoS plan in Australia East region. And let's go ahead and create our DDoS protection plan. So unlike Azure Front Door or Application Gateway, these kind of WAF or DDoS protections are not going to be specified on the load balancer itself. Instead, it's going to be specified on the VNet level. So let's go to the VNet we have created before. And then let's go to DDoS protection. And then let's enable it. And from there, we will be able to select our DDoS plan we have created before. Let's go ahead and save our changes. This is will provide a DDoS protection for all resources hosted in this VNet. And our load balancer is hosted in this VNet. So it's going to be protected from DDoS attacks. That's all I have for you in this video. Now, let's go ahead and clean things up. We have been using so many resources for the last few videos. So let's go ahead to Sydney resource group. And let's delete the resource group to delete all resources we have created in the last few videos. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this section, we are going to talk about load balancer components. And we're going to see in more details what are the different SKUs available in Azure Load Balancer, and different types as well, like internal, global, and gateway load balancers. We are going to dive deep into the backend pools and the front-end IP configuration. And we are going to see the zone redundancy and inbound, outbound rules. Let's get started and let's jump straight into it. Hi everyone. In this video, we are going to dive deep into load balancer configuration, specifically the basic configuration of our load balancers. So let's go ahead and browse to load balancers and go ahead and create one. I'm not going to create a new load balancer anymore because we have created so many load balancers in previous videos. But I'm gonna walk you through different steps and configurations you need to be aware of when you create your load balancer. Of course, you need to specify a resource group, name and region for your load balancer. Then you will get to specify SKU. And you get to choose from 3 tiers, either standard, basic, or gateway tiers. Let's leave gateway tier aside for now because we are going to cover it in more details in a separate video. And for the main difference between basic and standard tier, you will be able to find more details about it on this link. And as you can see here, it's a comparison between the main features between basic and standard load balancers. And at a very high level, standard load balancer should be used in a production workloads because standard load balancer supports high network performance and zone redundancy, while the basic load balancer doesn't support many options, as you will be able to see in this table here. And it's important to understand the main differences between these two tiers before you go ahead and create your load balancer in Azure. Now, that's for the main differences between standard and basic load balancers. And now, when we get to choose the type of our load balancer, we get to choose from either public or an internal load balancer. And we have already seen in previous videos what are the differences between public and internal load balancer. Public load balancer allows your load balancer to be able to accept traffic coming from the public internet, while the internal load balancer only restricted to accept traffic from within your VNet. And then finally here you get to choose the tier of your load balancer, whether it's regional or global. I said it before and I will say it again. For the global load balancer, make sure that you are hosting your global load balancer in one of the home Azure regions. The portal will allow you to do it, but when you try to go and deploy it, it won't be a successful deployment. Like I can go ahead now and specify settings for a global load balancer in Australia East region. The portal will be okay with that. But when it comes to the deployment, it will fail because Australia East is not one of the Azure home regions for load balancers. It's important to keep that in mind. That's all I have for you for the basic settings of our load balancers. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the front-end IP configuration of load balancers. Now let's go to load balancers and create a new one. Let's put it in a resource group. Let's call it load balancer. Let's select the public type and let's go to the next step. Now let's go ahead and add a front-end IP configuration. In here, we get to specify a name for our front-end IP configuration. Then we will get to choose between the IP version. Could be IPv4 or IPv6. And then we'll get to specify the IP type. Could be IP address or IP prefix. And we are going to see both in this video. Now for the public IP address assignment. If you already have a public IP address created in your subscription, you can go ahead and select it from here. However, if you don't have, like myself, you will need to go ahead and create a new public IP address for your load balancer. And as you can see, the first step you need to do here is to specify a name for your public IP address. And you will be able to see that there are some pre-selections has been already done for us, and we can't change it. For the SKU of the public IP address, it could be either basic or standard. Standard should be used in production workloads. And basic tier doesn't support zone redundancy. And for the public IP address tier, it could be either regional or global. And this is linked to the load balancer configuration we have specified in the first step. When we have created a regional load balancer, then we are going to have a public IP address in the regional tier. However, if we have created our load balancer to be a global load balancer, then the public IP address will be in the global tier. And for the availability zone, you should go for zone redundant if you want to have a resilient load balancer and a resilient architecture. Having said that, you will still be able to choose a specific zone to deploy your load balancer if you want. Or maybe if you want to choose to go for no zone at all, you will still be able to do that. If we have selected a basic load balancer in the first step, we wouldn't get a chance to specify which zone. Now for the routing preference, we can choose either from routing the traffic through Microsoft Global Network or routing the traffic through your internet service provider. You could choose from either of these. However, the recommendation is to choose Microsoft Global Network. And this is the configurations we need to do when we create a public IP address for our load balancer. Now let's go with the second option, IP prefix. And the main difference in the IP prefix, you will get to choose a reserved range of Azure public IP addresses instead of just one public IP address if you selected IP address type. And similar to the IP address type, you will need to specify the zone redundancy option or availability zone option. And again, zone redundancy will be the best option to have a resilient architecture for your load balancer. For the gateway load balancer, you might remember in a previous video when we have created the gateway load balancer, we had been able to assign it to our standard or basic load balancer from the configuration. You are still able to assign the gateway load balancer to your standard or basic load balancer at creation time. And since I don't have any gateway load balancer at the moment, we can't choose from any for now. These are the different options and configurations you need to be aware of when you get to create your front-end IP address configuration. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video we are going to talk about the backend pools in our Azure load balancer. But as a first step, let's go ahead and create a virtual network first. Let's go ahead and create a new one. And let's create a new resource group. Let's call it RG Backend. And let's call our VNet Sydney. And let's put it in Australia East region. And let's go ahead and create our VNet. Now let's browse to our load balancer. And let's go ahead and create a new one. Let's put it in RG Backend. Let's call it LB. Australia East Public Regional. Now let's go to the front-end IP configuration and let's call it IP. And for the new public IP address, let's call it public IP. And let's go to the next step, backend pools. And as you can see, you can add a backend pool to our load balancer. We can call it backend, for example. And here is why I've created a virtual network in this video. Because we will need to specify a virtual network for our backend pool in the Azure load balancer. And we get to choose from one of the two options. Either we configure our backend pool based on the NIC, which is Network Interface Card of our virtual machines. Or we can configure our backend pool based on the IP addresses of our virtual machines. These are the two options available for us to configure our backend pool for our load balancer. And since I don't have any resources at the moment, I will not add anything into our backend pool. I just showed you the different options we have, or different backend targets we could have in our backend pool in the Azure load balancer. That's all I have for you in this video. Now let's clean things up. So I'm gonna go to resource groups and I'm gonna go to RG Backend. And let's go ahead and delete the resource group. Thanks for watching. I will see you in the next video. Hi everyone. In this video we are going to talk about the inbound rules. And to be more specific, we are going to talk about the load balancing rule. Now let's go ahead and create a load balancer. Let's put it in resource group. Let's call it LB, standard public regional. And let's create a front-end IP configuration. Let's call it IP. And let's create a public IP address. Let's call it PIP. And let's go ahead and add the backend pool. I'm gonna add an empty pool. And let's go to the next step, the inbound rules. And let's go ahead and add a load balancing rule. And as we have seen before, we will get to specify a name for our rule. Let's call rule 01. Then we will get to choose the version of the IP address. Then we select the front-end IP address of our load balancer and which backend pool we want to send the traffic to it. And for the protocol here, it could be either TCP or UDP. And there is no HTTP or HTTPS, as you might notice. And the reason for this is the load balancer operates at layer 4. It doesn't support layer 7 HTTP, HTTPS traffic. So let's keep the protocol to TCP protocol. Now for the port, this is going to be the port number associated with the front-end IP address of our load balancer. And for the backend port, this is the port. It's going to be on the instance in the backend pool that we want the load balancer to send the traffic to the VM in the backend pool on the backend port. So let's put port 80. And for the health probe, it's a way for the load balancer to know the health status of the backends in the backend pool and only forward the requests to the healthy backend instances. We are going to dive deep into the health probe in future, but for now, let's just create a new one, health probe TCP, And now let's get to session persistence, which is a way to maintain the traffic between the client and the virtual machine in the backend pool. So we have three options: either to not configure session persistence at all, or we could configure the session persistence based on the client IP address. So the successive requests coming from the same client IP address, it's going to be directed and handled by the same VM machine in the backend pool. Or we could configure our session persistence to be a combination of client IP address and protocol. And this will ensure that all successive requests coming from the same client IP address and the same protocol will be handled by the same VM machine in the backend pool. Now let's keep it to none for now. And for the ideal timeout, this is how long to keep the connection open without relying on the client to send keep alive messages. Now we are coming to the TCP reset, and we are going to cover it in more details in a future video. And it's a way that allows the load balancer to send a TCP request to create a more predictable application behavior when the connection is ideal. And finally here we have the floating IP, and we are going to cover it in more details in a future video. And final step we have here is the outbound SNAT, and you should go with the recommended option to use the outbound rules to provide the backend pools with access to the public internet. So these are the different options we can use when you create or add a new load balancing rule into our Azure load balancer. And in the next video we are going to see how we are going to add an inbound NAT rule. Thanks for watching, and I'll see you in the next video. Hi everyone, in this video we are going to talk about the inbound NAT rules. And let's go ahead and create a new load balancer. Let's put it in a resource group. Let's call it LB, Australia East Standard Public Regional. Let's create a front-end IP address. Let's call it IP, and let's create a public IP address. Let's call it PIP. And let's create a backend pool. Let's call it backend. And let's keep it empty. Now let's go to the inbound rules. In the previous video we have talked about the load balancing rule, but now we are going to add an inbound NAT rule. And we are going to see the difference. And the first thing we need to specify here is a name for our NAT rule. Let's call it rule 01. And we have two types of NAT rule. Either it could be an Azure virtual machine or it could be a backend pool. And we are going to see both in this video. Let's go ahead first with the Azure virtual machine. We will need to specify the target virtual machine of this rule. And then we'll need to specify the front-end IP address of our load balancer and the front-end port of our load balancer. Then we'll get to specify the service tag. Let's say it's going to be HTTP, and then the backend port, we're going to make it 80. The backend port, it's going to be the backend port of the VM that the load balancer is going to send the traffic to it. And then choosing the protocol again, either TCP or UDP, because load balancer operates at layer 4. It doesn't support HTTP or HTTPS traffic. And then same settings we have seen before in the load balancing rule, whether enable or disable TCP reset, and specify the ideal timeout, or enable or disable floating IP. These are the settings or configuration you need to be aware of if you are gonna create an inbound NAT rule for Azure virtual machine. Now let's see what we need to do if we are gonna go for backend pool instead of Azure virtual machine. For the backend pool, we will need to specify or choose the backend pool for our inbound NAT rule. And same as before, front-end IP address of our load balancer, and it's gonna be the IP address of our load balancer. And then we need to specify the port number of our load balancer. And as you can see here, we currently have 0 number of instances in the backend pool, and this is where we specify the maximum number of VMs in the backend pool. And again, this is gonna be the backend port on the VMs in the backend pool. Protocol, it's gonna be either TCP or UDP, and same as the previous settings. This is all I have for you for the inbound NAT rule, and we have already created one NAT rule in a previous video. That's all I have for you in this one. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about the outbound rules in the load balancer. So let's go ahead and create a new one. Let's put it in Sydney resource group. Let's call it LB, standard, public, regional. And again, let's add a front-end IP address. Let's call it IP. Create a public IP address, call it PIP. And let's create a backend pool. Let's call it backend. And let's leave it empty. Let's skip the inbound rules and just go straight to add an outbound rule. Now, for the outbound rules, it's important to mention that this tab is only valid for the public load balancers. It's not going to be available for the internal load balancers or the basic load balancers. Having said that, it's not recommended to configure the outbound rules for the backend pool instances in the outbound rules in the load balancer. The recommended way to do it, as we have done it before in our videos, is to create a NAT gateway to provide outbound internet access for the backend pool. However, I'm gonna show you how you can define an outbound rule in the load balancer. Now, first thing we need to do is to specify a name for our rule. Let's call it rule 01, and then we get to choose the IP version. It could be either IPv4 or IPv6. Then we select the front-end IP address of our load balancer, and then we select the protocol, could be TCP or UDP or all. Then we specify the ideal timeout and whether TCP reset is enabled or not. And of course, we will need to choose the backend pool. And when it gets to the port allocation, we have two options. Either to manually configure the number of outbound ports, and this is the recommended way of doing it, or we just use the default number of outbound ports. The risk of using the default number of outbound ports that we might run into SNAT port exhaustion. And that's why it's better to manually be in control of the number of the outbound ports. And then, as you can see here, we get to choose it per instance or based on the maximum number of the backend pool instances. If we're gonna choose it per instance, we get to specify how many ports per instance. Let's say 1000. This is how we configure an outbound rule in the load balancer to provide an outbound internet connectivity to the instances in the backend pool. However, it's not recommended to create or configure the outbound rules in the load balancer itself. It's better to create a NAT gateway and configure your outbound rules in the NAT gateway. That's all I have for you in this video. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about the availability zones in the Azure load balancer. And let's go ahead and create a load balancer. Let's put it in Sydney resource group. Let's call it LB, Australia East, standard, public, regional. And let's go ahead and add a front-end IP configuration. Let's call it IP, and let's create a new public IP address and call it PIP. And here is the option we are going to talk about it in this video, the availability zone. And if you remember in previous videos, we had few options to choose from when it comes to the availability zone of the public IP address of our load balancer. And the most resilient option we could choose is the zone redundant. And it's recommended to use zone redundant option when you go for production deployment. And we are going to talk a little bit more about why zone redundancy is a really good option. So in any Azure region, there are gonna be 3 or more availability zones. Zone 1, Zone 2, and Zone 3. And when we configure the availability zone of the public IP address of our load balancer to be zone redundant, then we are going to have a single front-end IP address that is going to serve the traffic to all healthy backend instances in any availability zone. No matter where they are, we are going to be able to send the traffic to these instances as long as they are healthy and in a healthy zone. Now, let's assume that we had a complete failure in one of the availability zones. Still, using this single front-end IP address, we will still be able to direct the traffic to all healthy instances in other healthy availability zones, which mean zone 2 and zone 3. We should be able to survive sending the traffic to all healthy instances in these two zones. And let's take it one step further. Let's say that zone 1 is completely out and zone 2 is completely down. Now we have only zone 3 is available. And still, as long as we have configured the availability zone of the public IP address to be zone redundant, having this single front-end IP, we will still be able to send the traffic to the healthy instances in zone 3, as long as zone 3 is a healthy zone. So briefly, having a single front-end IP address with a zone redundant option will help us to survive the failure of multiple availability zones, as long as we have at least one healthy availability zone that has healthy instances in it. And this is the power of having zone redundant option for the public IP address for the load balancer. And if we get back to the Azure portal, there are gonna be other options we could choose from. Like we could choose our deployment, the public IP address to be in a specific zone, either 1 or 2 or 3. So, and this is gonna be called the zonal deployment. And when we go for a zonal deployment, then we are going to have a single front-end IP address for each load balancer in each availability zone. And it's going to be responsible to send the traffic to all healthy instances in this availability zone. And our front-end IP address in zone 1 will not be able to send the traffic to the healthy instances in zone 2, because we have only a zonal deployment for the public IP address for our load balancer. And having said that, we are going to have a front-end IP address for the load balancer in zone 2 and similarly for zone 3. Each of these IP addresses for each of these zones are going to be separate and independent of each other. Now, if we want to have some kind of load balancing for the traffic between all of these zones, we could use Traffic Manager on top of all of these to send the traffic to the healthy availability zones or to healthy load balancers in different availability zones. And this is the zonal deployment of the public IP address for the load balancer. And if we go back to the Azure portal, and the last option we have is no zone. Like simply we are going to create our public IP address and is not attached to a specific zone. So these are the different availability zone options we could choose from for our public IP address. It's important to know some limitation. We cannot change the zone once we have created it. Like if we have created our public IP address to be in zone 1, we will not be able to change it to be to zone 2 in future. And if we have configured our public IP address to be in a zonal deployment and we wanted to change it to be a zone redundant, we won't be able to do that. And the other way around. If we have configured our load balancer to be zone redundant, we will not be able to change it to a zonal deployment later on. This is kind of known limitation of the zone redundancy option in different Azure services. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video we are going to talk about the cross-region load balancer, or some people like to call it the global load balancer. It's important to mention that as of March 2023, cross-region load balancer is still in preview and it's not recommended for production workloads yet. The main use case you want to consider using a cross-region load balancer is when you have something like this. when you have regional load balancers deployed in different Azure regions, and you want to have a load balancer with superpower that sits on top of all of these regional load balancers that will be able to distribute the traffic to these load balancers according to the incoming traffic coming from the user. So the main use case for having the cross-region load balancer is to enable geo-redundant high availability scenarios when your incoming traffic coming from multiple places or multiple regions around the world. One of the main benefits we are going to get when we use a cross-region load balancer is we get an instant global failover to the next optimal region. And we are going to see how. Now let's assume that we have 3 regional load balancers deployed in different regions around the world. And then we have deployed a cross-region load balancer that sits on top of all of the 3 regional load balancers. Now let's assume that there is a failure happened in one of these regional load balancers. Then what's going to happen is that the user is going to get directed to the closest regional load balancer. And when I say closest, I don't mean closest from the geographic perspective, but closest from the network latency perspective. And this is what the cross-region load balancer is going to do. By sending different health probes and health checks to these regional load balancers, the cross-region load balancer will be able to detect a failure in any of these regional load balancers. And once it detects a failure in any of these regional load balancers, it's going to take it out and then sending the traffic to the next optimal destination based on the user location or based on the originating traffic. And also having a cross-region load balancer will give you the ability to scale up and down behind each of these endpoints separately. Because for each of these regional load balancers, we will be able to add more instances, remove more backend pools as much as we like, based on the workloads we are receiving from the clients. Also, we are going to have one static global IP address for the cross-region load balancer that is going to serve the traffic to all of these regional load balancers in different regions around the world. And one of the key things in the cross-region load balancer, it preserves the client IP address. Another key feature of the cross-region load balancer is the client IP address preservation. Like when the client sends the request to the cross-region load balancer, the cross-region load balancer will still forward the client IP address into the regional load balancer onto the backend applications. In case you have some algorithms or some filtering happens based on the user location, you will still be able to do that. And as we said before, when you go deploy your cross-region load balancer, you need to make sure that you are deploying it in one of the home regions. Because if you deployed your global load balancer in a participating region, the portal won't complain as of March 2023, but you won't be able to deploy it at the end. So you need to be mindful of that. Now, let's talk a little bit about some limitations for the cross-region load balancer. First of all, it only works for public scenarios. We cannot have internal cross-region load balancer as of now. Also, we cannot have internal load balancer as a backend target in a backend pool of the cross-region load balancer. And also, UDP traffic is not supported in cross-region load balancer, only TCP traffic is supported. That's all I wanted you to know when it gets to the cross-region load balancer. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the gateway load balancer. And if you remember, we have 3 types of load balancers: public, internal, and gateway. And gateway load balancer is created for scenarios that require high performance, high availability, and requires an integration with a third-party network appliance, like a firewall, packet analysis, traffic mirroring, DDos protection, etc. And the way it works, as we've seen before in a previous video, that we are going to chain the gateway load balancer with other load balancers we have in our solution. This will allow us to easily add or remove network appliance in the network path without changing the whole architecture, because everything is going to be attached to the gateway load balancer, which is chained to the standard load balancer. And then we are going to attach all of these network appliances into the gateway load balancer as much as we like. And then when it gets to the supported partners to be integrated with the gateway load balancers, this list shows you the different partners you could work with to have their network appliance integrated with your gateway load balancer and then chained with your standard load balancer. That's all I have for you for the gateway load balancer. Thanks for watching, and I will see you in the next video. Hi everyone. In this section we are going to talk about the inbound connectivity in Azure Load Balancer. We are going to look at the inbound NAT rules in more details, and the high availability ports, and how we can configure multiple front ends and use a floating IP for the inbound connections. And also you're going to touch on the TCP reset in Azure Load Balancer. Let's get started and let's jump straight into it. Hi everyone. In this video we are going to talk about inbound NAT rule, and we have talked about it in previous videos already, but we are going to cover it from a different perspective. Now let's go ahead and create a load balancer. You don't have to follow along with me and create a load balancer. I'm going to create a dummy load balancer to just help me explain on different areas in the load balancer. So let's go ahead and create a load balancer. I'm gonna create a new resource group. I'm gonna call it RG Sydney. Gonna call my load balancer LB. Gonna put it in Australia East region, standard, public, regional. And then let's create a public IP address for my load balancer. Call it IP, and then create a public IP address. Call it PIP. And let's create an empty backend pool. Let's call it backend, and let's save it. I'm not gonna define any inbound or outbound rules at the moment. Let's go all the way down and create our load balancer. Now my load balancer is ready for me, and let's go to my load balancer. Let's go to inbound NAT rules. I want you to keep in mind that there is a specific use case where the inbound NAT rule are going to be extremely useful for you. Inbound NAT rule simply is used for port forwarding. Port forwarding allows you to connect to a virtual machine in the backend pool by using a combination of front-end IP address and a port number. And we have already done it in a previous video, so feel free to get back and review the video if you want. And what we have done in that video, we have configured different port number for different virtual machine we have. So when the incoming traffic hits the front-end IP address of the load balancer and port 500, then the traffic is going to be forwarded to this virtual machine. However, if the traffic coming to the front-end IP of the load balancer and port 501, then the traffic is going to be forwarded to the second virtual machine. So the load balancer is going to receive a traffic on the front-end IP address of the load balancer and a port number. And based on the inbound NAT rules and how we have configured it, then the load balancer is going to forward the traffic to a specific virtual machine, as we have already seen in a previous video. And you might have noticed that there is something wrong in this design. That, for example, if this virtual machine has been completely unavailable for any reason, then all of the traffic on port 500 will go nowhere, because we don't have any load balancers or any more virtual machines to take up the incoming traffic on port 500, since the primary virtual machine is down. So this is one consideration you need to keep in mind when you use a single virtual machine for the inbound NAT rule. And as a way to overcome this, you can use the other option. And as you remember here, you specify the start range of the front-end port and the maximum number of instances in the backend pool. And based on that, the allocation and deallocation of new virtual machines that are going to be added to the pool are going to happen automatically. So the main difference between the two options is that in the first scenario, we explicitly define the port number or each port in our load balancer and where we want to direct the traffic that are hitting this port. However, in the backend pool, we have a little bit more flexibility where we are defining the starting port number and the maximum number of instances. And based on our scaling activities in the backend pool, the port allocations is going to happen automatically with the inbound NAT rule to register or deregister virtual machines as they've been added or deleted from the backend pool. This is very important to keep in mind when you are architecting or designing your solution using inbound NAT rule, because you want to make sure that you are not introducing a single point of failure for an incoming traffic that is hitting a specific port. That's all I have for you in this video. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about high availability ports in the Azure Load Balancer. So let's head to Azure Load Balancers and let's go to our load balancer. That's the public load balancer. And if I'm gonna go to load balancing rules and let's go ahead and add a new rule. As you can see here, we don't have high availability ports available in the public load balancer because it's something only available for internal load balancer. So this is an internal load balancer I've created. I'm gonna browse to load balancing rules. By adding a new rule, you should be able to see HA ports available for you to use. And HA ports provides an easy way for you to load balance all the flows on all ports that are arriving on your internal load balancer. So the decision is gonna be made per flow according to a combination of 5 things: source IP address, source port, destination IP address, destination port, and protocol. And HA ports is going to be used in critical situations when you want to ensure you have high availability or you provide high scalability for your network virtual appliance inside your virtual network. Also, when you have a large number of ports that must be used or must be load balanced. And the way to configure it is pretty easy. You just tick on the checkbox of high availability ports. So by checking this checkbox, you have enabled high availability ports on your internal load balancer. And I'm not gonna jump into the details of high availability ports from networking perspective because it's gonna be a completely different topic that we could cover in a different video. But that's all you need to know about high availability ports. It's only available in internal load balancer. It allows you to load balance all flows on all ports coming onto your internal load balancer. And it's extremely useful for critical scenarios, which require high availability for your network appliance inside your virtual network, or when you have a large number of ports to load balance. That's all I want you to know about the high availability ports. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about how can we enable multiple front-end IP addresses on our Azure load balancers. So let's go to Azure load balancers and go to our public load balancer, load balancing rules, and let's go ahead and add a new rule. And in here, we get to specify different information about front-end IP address, backend pool, and the port on the front end, and the backend port. And we have kind of one rule we need to apply at all times. The destination IP address and port number has to be unique across all load balancing rules. Now let's go ahead to the documentation to understand this in more details. So let's assume that we have these different load balancing rules. And as you can see here, we have the same IP address in the first 3 rules. And we have a different IP address in the 4th one. So the 4th one should be alright because it doesn't conflict with any other rule. However, for the top 3, it uses the same protocol for the first and second, but they are on different ports, so we should be alright without any problem. But the third rule is using port 80, but should be fine because we are using a UDP protocol, not TCP. So the main rule that we need to keep in mind when we get to define our load balancing rules, that the combination of the destination IP address and destination port has to be unique across all load balancing rules. Now, if we go to see how we are going to implement this, let's assume that we have two IP addresses in our load balancer and we want to spread the traffic to two VMs. So we are going to have public IP address 1 and it's going to be configured on TCP protocol, sending the traffic on port 80. And same thing for IP 2. Now, when we want to map these IP addresses to backend pool, we are going to configure the front-end IP address number 1 to get directed to the backend instance IP address number 1 and listen on port 80. And we are going to send it to the backend instance IP address number 2 on port 80 as well. And it shouldn't be any problem because these two M's are completely separate. But if we wanted to configure the front-end IP address number 2 to send the traffic to the backend instance IP address number 1 on port 80, it won't work. The portal actually is going to stop us from doing this because it has to be a unique combination of the destination IP address and destination port. And this has to be unique across all load balancing rules. But if we try to configure the front-end IP address number 2 to send the traffic to the backend instance IP address number 1, but on a different port, and in this case it's going to be 81, it should accept it without any issues. Similarly, if we configured it to send the traffic to the backend instance IP address number 2 on port 81, the portal will accept it and it's not going to be any issues. And this is going to be the final result we will be able to see on the portal, having the front-end IP address, the protocol, port number, and then the destination IP and port. Now, this was the scenario where we want to not allow backend port reuse. But what if we want to allow backend port reuse? Now, for the other rule type we can create is we can allow a backend port reuse by using floating IP address. But first, let's talk a little bit about why we want to consider allowing backend port reuse in our rules. We want to do this for multiple reasons. First of all, you want to have clustering to enable high availability, or you want to use it for network virtual appliance, or you want to expose multiple TLS endpoints without re-encryption. So these are the few scenarios where you want to consider using the backend port reuse by enabling floating IP on your load balancing rule. For the floating IP, if you don't remember, if I'm going to go back to the load balancing rule and scroll all the way down, you should be able to see the floating IP address checkbox, and you can enable it by just ticking off the checkbox here. Now, let's get back to the portal. As you can see here, we have two IP addresses configured for the load balancer, and they are sending traffic to different VMs on the same port without any issues. But in order to do this, we need to create additional interfaces on the backend VMs. As you can see here, the VM originally comes with a backend IP address, which is the NIC interface of the VM. But we are going to create additional loopback interface within the operating system, and it's going to be configured with the IP address of the public IP address or the front-end IP address of the load balancer. And we are going to see this in a bit. Now, let's look at this table here. Now we are going to have IP address number 1 and the front-end IP address number 2 on TCP protocol. Both are sending traffic to port 80. And when we get to map it, while we're enabling a floating IP address, then the front-end IP address number 1 is going to send the traffic to front-end IP address number 1 on port 80, which has already a loopback interface on both VM1 and VM2. And similarly for front-end IP address number 2. So this is going to be the end result we are going to see in the portal, having the front-end IP address and the protocol, and the destination in this case, it's going to be the same as the front-end IP address, because we already have configured the loopback interface for both VMs and the front-end IP address. And this is exactly what floating IP means. It allows you to reuse backend ports in your load balancing rules. And if you want to go ahead and configure, and again, this is another diagram that explains how things looks like before and after floating IP. As you can see here, before floating IP, we receive the traffic through the front-end IP address of the load balancer, and it gets directed to the destination IP address of the VMs at the backend pool. But after we enable floating IP, again, we are going to receive the traffic as we are through the front-end IP address, but it's going to get directed to the VIP, which is going to be the same front-end IP address, as we have already built a loopback interface on these two VMs. How can we create a loopback interface? Actually, this guide here is going to explain to you how can you create a loopback interface on these two VMs, whether you are using a Windows server or Linux. And as we are here, there is a bit of limitation when it gets to the floating IP address. Like you cannot using the floating IP on secondary IP configurations for load balancing scenarios. That's all I want to share with you for floating IP and multiple front ends for the Azure Load Balancer. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about TCP reset in load balancers. So let's go to load balancers, and let's browse to load balancing rules, and let's add a new rule. You will see an option for us to enable TCP reset. And it's not only restricted to load balancing rule. We can go ahead and enable TCP reset for inbound NAT rules and for the outbound rules as well. So for any rules in load balancer, we can go ahead and enable TCP reset. And it's tightly linked with the ideal timeout that we need to configure in minutes here. So what's the benefit of having TCP reset enabled on a load balancing rule? It allows you to have a more predictable application behavior for your scenarios by enabling TCP reset based on the ideal timeout on the load balancing rule. And once this ideal timeout has been reached, the load balancer is going to send a bidirectional TCP reset request, so they can kill the current session and close all connections happening on this session. And any future requests are going to be sent on the same session are going to be ignored and is going to be failed. Because when we send the TCP request to both client and server, both close the correspondent socket immediately. And of course, they can allocate a new socket, establish a new connection if there is a new requests coming through. But if there is no more new connections coming through, then we are going to send a TCP request to just drop the current session and close the corresponding socket immediately. It's a good way to preserve the resources on both the load balancer, client, and server to kill the sessions that are not been in use anymore. That's all you need to know about the TCP reset. Thanks for watching, and I will see you in the next video. Hi everyone. In this section, we are going to talk about the different outbound connectivity options we could configure in our Azure Load Balancer. We will see how can we enable the outbound connectivity through the load balancer itself, or through a NAT gateway, or through the public IP address of a VM. And also we are going to look at how we can implement egress-only traffic using the load balancer. So let's get started and let's jump straight into it. Hi everyone. In this video, we are going to talk about the different options we can use to provide an outbound connectivity to Azure Load Balancer. And this table summarizes it well. First option we have is to use the front-end IP address of our load balancer to have or to provide an outbound connectivity to the internet. But there is an issue with that approach. As you can see here, it's a static, which means it won't provide so much scalability into the solution. And therefore, it won't be recommended for production workloads. But we can still use it without any issues. The second way we can use is to associate a NAT gateway to the subnet. And this is going to be a dynamic and explicit. And this is actually the recommended way to provide an outbound connectivity to the load balancer. We are creating a NAT gateway as we have seen before in previous videos and associate the NAT gateway to the subnet where our backend instances exist. And by doing this, we will have so much flexibility to add more instances to the subnet where the NAT gateway is associated. As we said before, and we are going to say it again, it's going to be the best way to provide an outbound connectivity to the public internet through the Azure Load Balancer is to associate NAT gateway to the subnet where the backend instances exist. The third option we could use is to assign a public IP address to the virtual machine directly. This one is going to be static. It won't allow so much flexibility to scale to multiple instances if we want to, because we are going to have only one public IP address per VM. And of course, we can use this for production workloads. And the last option we have is to use the default outbound access at the VM level. And it's going to be implicit allocation. And it's not recommended for production workloads. And by looking at this diagram here, it shows some of the options we have talked about before. The first option we have is to use or assign a public IP address to the virtual machine directly. However, this option wouldn't provide much scalability as our workloads grow. And the second option we have is to use the front-end IP address of the Azure Load Balancer to provide an outbound connectivity to the internet. So all of the instances in the backend pool are going to use the public IP address of the load balancer to be able to access the internet. But in this approach, we need to do the port allocation manually upfront. And the last option we have is to associate a NAT gateway at the subnet level where the backend instances exist. And in this case, all of these VMs are going to use the NAT gateway to be able to access the internet. And it's going to be completely separate from the front-end IP address of the Azure Load Balancer. Now let's dive deep into all of these options one by one. And the first one we are going to talk about is using the front end of the Azure Load Balancer to provide an outbound connectivity to the internet. And in order to do this, we will need to create an outbound rules at the load balancer level, which uses SNAT ports. SNAT stands for Source Network Address Translation. As we have highlighted before, we can use the SNAT port approach. However, it's not dynamic and it won't allow us to scale as our workload increases. And therefore, we will need to specify the port allocation manually at the load balancer level to allow the outbound connectivity using the SNAT port of the load balancer. The second approach we have talked about is to use the NAT gateway to provide an outbound connectivity to the internet. And it's going to be a separate flow from the public IP address of the load balancer. And by using the NAT gateway, we are going to allow outbound connectivity only to the internet. And again, it's going to be the best way for you to use to provide an outbound connectivity to your environment. NAT gateway is extensible, reliable, and doesn't have the same issues of the SNAT port exhaustion. Now the third option we could use is to assign public IP address on each of these VMs separately. And as you already see, this is not a scalable approach because we will have to specify or associate each of these IP addresses to different VMs we have in our environment. And if we are going to associate a public IP address to a VM, it doesn't matter if the VM is behind the load balancer or not, because the traffic flow is going to be different. By associating a public IP address to the VM, we are dictating another way to allow the outbound traffic from the VM to the public internet. However, through the load balancer, we are allowing the inbound traffic to the VM through the load balancer. And the last option we have is to use the default outbound access of the VM to allow an access to the public internet. In this scenario, we don't have a public IP address associated to the VM. And the VM sits behind the load balancer that doesn't have any outbound rules. And the VM is not part of any VM scale sets. And the VM is deployed in a subnet that doesn't have NAT gateway associated at the subnet level. So in all of these 4 conditions met, we can use the default outbound access, or some people call it the implicit outbound access, from the VM to the public internet. Now let's get back to our documentation and talk about the SNAT port. At a high level, every IP address has kind of 65K ports. And each port could be used as a listener to allow inbound connection, or could be used for the outbound connection. Sometimes we call it ephemeral, which is temporary port allocation the load balancer allocates to allow the outbound connection to the internet. And you might have already sensed the problem. We are using the same bucket of ports available per IP address to allow both inbound and outbound traffic to or through our load balancer. And in some situations, when you have a very heavy traffic running through your load balancer, you might run into SNAT port exhaustion, like you don't have any more SNAT ports to provide for any outbound connectivity for your environment, and then it's gonna be a problem. And if you might say that, okay, let's go ahead and add more front-end IP addresses so we can have wide range of ports we can use. This could be an option, however, and if we look at this example here, let's assume that we have provided 2 front-end IP addresses to allow more ports for our load balancer. And we have 2 backend instances are allocated for 64K ports. What's gonna happen is that both backend instances are going to consume all ports defined or configured in the first front-end IP until all of these ports is exhausted. The backend instances are not going to balance the usage of the ports across 2 front-end IP addresses. And this is the default port allocation table for the backend pool size based on the number of instances in each pool. Now let's talk about the port exhaustion. And you might have already know what does it mean. It means when we don't have enough ports to allocate to provide an outbound connectivity to the internet. And of course, one of the reasons we might get this is when we are using the front-end IP address for both inbound traffic and outbound traffic. Especially if you're having higher workloads, you're increasing the chance for a SNAT port exhaustion to happen in your environment. And the way to avoid this is to use NAT gateway at the subnet level instead of using the outbound connectivity for your Azure load balancer. Now, finally, here we are going to talk about some constraints you need to be aware of when it comes to the SNAT port exhaustion. And the most important thing I want you to know is that when you have a SNAT port exhaustion doesn't necessarily mean that the exhaustion happened at the load balancer level. Sometimes the load balancer can still have some SNAT ports available, but the backend instances ran out of SNAT ports, and then the backend instances cannot establish any new outbound connections. And then we are going to run into SNAT port exhaustion. So the main takeaway here is that when you get SNAT port exhaustion, try to analyze and see where exactly it happened, whether at the load balancer level or at the backend instance level. That's all I want you to know about the outbound connectivity for Azure Load Balancer and the SNAT port. Thanks for watching, and I will see you in the next video. Hi everyone. In this video we are going to see how can we implement egress only or outbound only connectivity using load balancers. And in this scenario we are going to use two load balancers. Internal load balancer, and we are going to configure it to provide an inbound connectivity to the VM instances sits in the backend pool. And then we are going to use a public load balancer to allow outbound connectivity to the VM instances to the outside world. And in this path, we are going to use the front-end IP address of the public load balancer. We are not going to use the default or recommended NAT gateway on the subnet approach to provide the outbound connectivity to the backend pool instances. Instead, we are going to use the outbound rule at the load balancer level to show you different options. So you know what are the different options you have in the portal, then you are free to use whatever works for you. Now let's go to the portal and see how can we implement this. Let's go to virtual networks and let's create a new one. Let's create a new resource group. Let's call it RG Sydney, and let's call our VNet Sydney as well. Let's put it in Australia East region, and let's go to security tab and enable Bastion host, and let's call it Bastion subnet. Let's make the address space 10.0.1.0/24. And let's go ahead and create a public IP address for our Bastion. Let's call it public Bastion IP. And let's go ahead and create our VNet. Alright, now my VNet has been created. Let's go ahead and create our load balancers. Let's start with the internal load balancer. Let's put it in Sydney resource group. Let's call it internal load balancer, Australia East standard internal regional. And let's go to the front-end IP configuration. Let's call it internal load balancer IP. And let's put it in the default subnet. And let's go ahead and create or add the front-end IP. Then let's go to next step and add a new backend pool. Let's call it backend and let's leave it empty. And let's go ahead and create our internal load balancer. Now let's go ahead and create a public load balancer. Again, let's put it in Sydney resource group. Let's call it public IP LB Australia East standard public regional. And let's go to the front-end IP configuration. Let's call it public load balancer IP. And let's create a new public IP address. Let's call it public load balancer public IP. And let's go ahead and add the front-end IP address. And let's create a backend pool. Let's call it backend. And let's leave it empty. And let's go ahead and create our public load balancer. Now, let's go ahead and create a virtual machine. Let's put it in Sydney resource group. Let's call it VM01. And let's choose a username and password for my VM. Now, since I have a Bastion host, I don't need to keep the RDP port open. So I'm going to disable it. Now let's go to networking and let's not create a public IP address on our VM. And let's allow the advanced network security group configuration. And let's allow inbound rule on port 80. And let's give it priority 100. And let's go ahead and add this rule. And let's go all the way down and create our virtual machine. Let's go ahead and create it. So what we have done so far is to just setting up the foundation. We have created a VM. It doesn't set in any backend pool yet. And we have created an internal load balancer and a public load balancer. And again, we haven't created any inbound or outbound rules yet. So what are we going to do next is to put our virtual machine in the backend pool for these two load balancers. So let's go ahead and do that. Let's go to load balancers. Let's start with the internal load balancer. Backend pool, backend, and let's add IP configuration. And let's select the VM we have just created. And let's go ahead and save our changes. And let's do exactly the same for the public load balancer. Go to backend pools, backend. Let's select the VNet that we have just created. I'm not sure why I'm getting two. Anyway, let's add a new IP configuration and let's select the VM we have created. And let's go ahead and save our changes. Now I assume the VM has been created. Great. Now let's go to our VM and let's connect to it using Bastion. So I'm going to use the username and password I used when I was creating the VM. And let's connect to our VM. So again, to reiterate, we have put our VM in the backend pools of both public load balancer and internal load balancer. And we have already, while we were creating the VM, allowed inbound rule to allow the inbound traffic coming from the internal load balancer to the VM. We haven't created an inbound rule at the internal load balancer for that, but we have created an inbound rule on the network security group for the virtual machine to allow the inbound connections coming from the internal load balancer. Now let's go to our virtual machine and let's browse to local server and let's disable IE enhanced security configuration. Now let's open IE and let's browse to what'smyip.org and see what are we going to get. Of course, we are not going to get anything because we haven't created any outbound rule on the public load balancer yet. There is no way out for the VM to get an access to the public internet. So let's go ahead and get back to our public load balancer and see how are we going to create an outbound rule to allow our VM to have an outbound accessibility to the internet. Now let's go ahead to the outbound rules. Let's go ahead and add a new rule. Let's call it outbound rule. And let's select the public IP address of the public load balancer. And let's select our backend pool. And let's choose the number of ports per instance. And let's limit it to 1000. You remember these are the options we have been talking about when it gets to the SNAT port and its exhaustion. Now let's go ahead and add this outbound rule. Again, this will allow our VM to have an outbound connectivity to the internet using the front-end IP address of the public load balancer. Now let's get back to our VM and let's refresh this page. As you can see, we are now getting some traffic because our VM now is able to access the internet through the public IP address of the public load balancer. And after we have configured an outbound rule on our public load balancer to allow our VM to get an access, to get an outbound access to the public internet. Again, this is not a recommended way to provide an outbound connectivity to your backend instances in the backend pool. Again, if you remember, as we said in a previous lecture, that you might run into SNAT port exhaustion if you have a really high traffic and have so many VMs set in the backend pool. A better way to do this is to create NAT gateway on the subnet level where the VM exists. That's all I want to show you in this video. Now, let's go ahead and clean things up. Let's go to resource groups, RG Sydney, and let's go ahead and delete our resource group. Thanks for watching, and I will see you in the next video. Hi everyone. In this section, we are going to see how can we use Azure monitoring to know the health status of our Azure load balancer. It's going to be a bit different from configuring the health probes to know the status, the health status of the backend instances in the backend pools. Now we are looking at Azure load balancer at a high level. We want to see how healthy our load balancer is. We are going to see this through insights, metrics, setting up diagnostic settings, and also setting up some alerts. So these are the things we are going to cover in this section. So let's get started. Hi everyone. In this video, we are going to talk about Azure Load Balancer Insights. So let's go to Load Balancers, and I'm going to create a dummy load balancer, so you don't have to follow along with me, just watch it and win. Let's call it RG Load Balancer, and I'm gonna call it Load Balancer. Australia East, Standard, Public, Regional. For the front-end IP configuration, let's call it IP. And let's create a new public IP address, call it PIP. And let's go ahead and add our front-end IP configuration. Now for the backend pool, let's call it Backend. And let's leave it empty. Now let's go ahead and create our load balancer. Alright, my load balancer has been created, so let's go ahead and browse to my load balancer. And if we scroll down here to monitoring section, you will be able to see the insights. And as you can see here, it shows you a graph of different IP addresses you have configured for your load balancer, different inbound, outbound rules, backends you have configured for your load balancer, and the backend instances or the VMs. So all of these things, you should be able to see it in this diagram. However, because I haven't created any backend instances, we can't see any at the moment. However, it should be similar to this. You have your load balancer front-end IP addresses, inbound, outbound rules, and then going to the backend pools you have configured, and then to the VM instances. And if you have a complex environment, when you have so many backend instances or so many backend pools, or when you have configured a lot of inbound or outbound rules for your load balancer, it's going to be really easy and quick if you have a graphical representation of your Azure load balancer configuration. And if we get back to the portal, we should be able to view a detailed metrics about our load balancer. We'll be able to see the front-end and back-end availability, data throughput, flow distribution, connection monitors, and metric definitions. All of these things are going to be available for you in the detailed metrics tab. That's all I wanted you to know about the insights of the Azure Load Balancer. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to see how can we set up diagnostic settings for our Azure Load Balancer. So let's go to Azure Load Balancer, and let's go to my load balancer I have created. And if you scroll down to monitoring section and then go to diagnostic settings, you can go ahead and add a diagnostic settings. Let's call it diagnostic settings. And then you will get to specify what kind of data you want to push to the log destination that we are going to specify. So let's choose all metrics. And then when we get to the destination details, we could send our diagnostic settings, and in this case, all of our load balancer metrics, to either log analytics workspace, and in this case, we will need to specify a workspace that we are going to push all of these metrics to the log analytics workspace. Or we could choose a storage account. Assuming that we have a storage account in our subscription, we could be pushing all of these metrics to a storage account as well. And we can send it to Event Hub in case if we have one in our environment, or we can send it to a partner solution. We can send the metrics to all of these things at the same time. However, it's going to incur an additional cost for you that you need to be aware of. However, as a minimum, you should be able to send or push your metrics to one of these destinations. That's all I have for you for the diagnostic settings. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about load balancer metrics. So if we go to our load balancer and scroll down to metrics, you should be able to see different metrics you are able to use to get more data about your Azure load balancer. We are not going to go through them one by one, but at a very high level, it gives you an overview about the SNAT ports status in terms of how many SNAT ports are allocated, how many SNAT ports are used, and what are the connection count of your SNAT port. Also, you'll be able to know the health status of the backend instances by observing the health probe status in the metrics of your Azure load balancer. And if you selected any of these metrics randomly, for each of these, you should be able to get the aggregation, whether by count, sum, average, min, max. That's all I have for you in the Azure load balancer metrics. Thanks for watching, and I'll see you in the next video. Hi everyone. In this video, we are going to talk about load balancer alerts. And the alerts comes hand in hand with the metrics. Like looking at one of the metrics here, when you create an alert, you need to link it or associate it with a specific metric. And then you are going to configure the alert based on a certain threshold, either above or below. Once this threshold is exceeded, either direction, then you are going to get alerted and notified about this metric. So let's say that we want to observe this metric, the number of SNAT connection count. Okay. Now, in here, you should be able to go ahead and create a new alert rule. And also, you should be able to browse to the alerts and select the metric from the alerts tab. So let's go ahead and do it. Let's click on create an alert rule. And the signal name here, it's going to be based on the SNAT connection count. And then we are going to make the threshold to be static based on the total number of the SNAT ports we have in our load balancer. And if it's gonna be greater than 65,000, for example, then we should get an alert. And this is gonna be based on a dimension. We could use one or more dimension to have more detailed view about this alert. We may be using the front-end IP address to be the front end of our Azure load balancer, or we could be using any connection state. However, I'm not gonna specify any dimension at the moment. Now we are gonna evaluate this criteria every 1 minute, and we are gonna look back over 30 minutes, for example. And then once this criteria met, we are going to get a notification that the SNAT connection count has exceeded the threshold value we have configured in our environment. Then we will get to specify the action. Like once this alert is triggered, we are going to assign it to a specific action group to get notified about this alert. Then we are going to specify some details. What sort of message we wanna put when this alert action group received this notification. Let's say SNAT port, its SNAT connection count exceeds the normal threshold. and then we can put more information in the rule description here. Then we get to create this alert rule. And then every time the SNAT connection count exceeds 65,000, as we have configured in our alert rule, then our action group is going to get notified about this condition. That's all I wanted you to know for the load balancer alerts. Thanks for watching, and I will see you in the next video. Hi everyone. In this video, we are going to talk about the logs available for us to use in our Azure Load Balancer. So let's go to Azure Load Balancer and let's scroll down to the monitoring section, and then let's go to logs. And in here, you should be able to see some pre-created queries you can use straight away to get more data and insights about your Azure Load Balancer. That's all I wanted you to show for the monitoring section. So far, we have covered everything in the monitoring at a very high level. Now, let's go ahead and clean things up. So let's go to resource groups. Let's go to RGLB, and let's go ahead and delete our resource group. Thanks for watching, and I will see you in the next video. Now we are coming to the end of our course. And over the last few hours, we have covered everything you need to know about Azure Load Balancer. I hope now you feel more confident about using Azure Load Balancer in different situations and different scenarios. Please let me know what you think about my course and what would be the best way to help you understand different Azure services. And until next time, thanks so much for watching.